We are given a reference angle is 30 degrees and its terminal side lies in quadrant 3. What are a possible positive and negative measure for the angle? So let's kind of sketch this out and see what's going on. It's my y-axis, x-axis, and we have a reference angle of 30 degrees. That terminal side is in quadrant 3. So here's quadrant 3. Reference angle is always based off of the x-axis, so I'd come down about 30 degrees. So here we go. We are given theta prime is 30 degrees. And here's my angle. And remember that initial side always starts on the positive x-axis. If we're moving in a positive direction, we're going counterclockwise. So that means my positive angle would be 180 degrees plus 30 degrees equals 210 degrees. And now if I want to do a negative measure, so negative measures move clockwise. So I start here at the initial side and I move this way. Now, if I'm going in a negative direction, I'm at 0 degrees here, negative 90 degrees here, negative 180 degrees here. So I haven't gone quite far enough to hit negative 180. So what I'm going to do is I'm going to take negative 180 plus the 30 degrees, and that puts me at negative 150 degrees. And number 2, let's convert negative 2 pi over 3 to degrees. So remember when you're doing these conversions, radians to degrees, degrees to radians, remember that there's 180 degrees in pi. So if I'm at a negative 2 pi over 3, I'm going to multiply that by, and the way I always remember it, I want whatever I'm trying to get rid of when I write this in the denominator. So I want to get rid of the radians, so I'm going to put pi in the denominator and the degrees in the numerator. So whatever you're kind of converting to, you could also think as well, you want that one in the numerator. So now what's going on here, my pi's cancel out. Also notice I can cross reduce here. 180 degrees divided by 3 is 60 degrees. So now I'm left with negative 2 times 60 degrees. That's negative 120 degrees. So negative 2 pi over 3 is equivalent to negative 120 degrees. Now let's go the other way. Let's convert 136 degrees to radians. So I start out with 136 degrees times, I want radians, so I'm going to put that in the numerator, and I'm trying to get rid of degrees, so degrees goes in the denominator. And now here, your units cancel out, degrees cancel degrees. If I look at this, let's just go ahead and write this out. We'll reduce 136 pi over 180. Okay, I'm going to reduce this fraction. 180 is divisible by 4. That would be 45 degrees, or 45 in the denominator. 136 divided by 4 would be 34. So I'm going to be left with 34 pi over 45. And now let's evaluate cosine of 5 pi over 3. On your test, you're going to need to identify the reference angle, the quadrant, and then evaluate it. So here we go. My reference angle, oh, that's super simple. Look at your denominator. Take away this 5. Your reference angle is pi over 3. We have 3 different reference angles that we use in the unit circle trigonometry. Pi over 3, pi over 4, and pi over 6. Those are the ones that you're going to see and you'll need to know and get yourself familiar with. So this one here is going to be pi over 3. My quadrant, oops, I started to write it. Let's take a look. So if you have call that the unit circle. We have an x-axis, a y-axis. I'm at 0 radians here. I would be at pi radians here. And then 2 pi. So if I rewrite pi, and again, I'm always using these reference angles. If I rewrite pi with 3 in the denominator, I get 3 pi over 3. So that means if I'm coming around, I hit here, I'm at 3 pi over 3. I go 1 more pi over 3. I'm here, that's 4 pi over 3. I would need to go another one to get to 5 pi over 3. So that means 5 pi over 3 is in quadrant 4. So there's our angle, 5 pi over 3. So then I need to determine what the cosine is. Well, if I look at my reference angle of pi over 3, I know cosine is 1/2. Sine at pi over 3 is square root 3 over 2. This is what I'm after, but I need to determine what should the sine be. Well, if I'm in quadrant 4, cosine is positive, sine is negative. So that means cosine of 5 pi over 3 equals 1/2. And now last but never least, the Pythagorean identity. So what is cosine theta? If sine of theta equals 17 over 20, and theta is in quadrant 2. So your Pythagorean identity just states you could have cosine squared theta plus sine squared theta equals 1. Just like the Pythagorean theorem, you have a leg squared plus leg squared equals the hypotenuse squared. And when we're on the unit circle, this is your horizontal leg. Remember, these are all forming special right triangles on the unit circle. Horizontal leg, vertical leg, your radius is 1, which is the hypotenuse. So let's just plug in what we know. I don't know cosine. Sine is 17 over 20 squared equals 1. And now we're just down to some computation. So I'm going to, let's see, we've got cosine squared theta. I don't need parentheses there. What am I doing? Don't need it. 17 squared is 289. And 20 squared is 400. And now I need to subtract this fraction from both sides. And when I do that, I already know that I have to have a common denominator. So if I just write 1 with the denominator 400, these are easy. It's whatever number you want in your denominator over itself. 400 over 400 minus 289 over 400. And then clean it up. 400 minus 289 is 111. And then I'm going to take the square root of both sides. So the square root of 111, I can't I can't reduce that anymore. So that's going to stay as the square root of 111. The square root of 400 I already know because, well, I had to square that same number to get to 400. So that would be 20. Now, let's not forget, we don't know if it's plus or minus. We're told theta is in quadrant 2. So if I'm over here in quadrant 2, notice your cosine values here are negative. So cosine is negative. So therefore, cosine of theta equals negative square root 111 over 20.